Hello, this is our first video lesson. This is 7.08. We're going to do operations with matrices. So again, you can print out a copy of this. I'll post it on Google Classroom. Or you're welcome to, if you don't have a printer, or if you prefer, you can just write everything down on a piece of loose leaf to record your notes. So basic matrix information. Matrices are named with a capital letter, just to name them. If two matrices are equal, that means that they have the same order. So the order we talked about was the number of rows by the number of columns. And all corresponding entries are equal if the two matrices are equal to each other. So this means that A sub 1, 1, which means A row 1, column 1 is equal to 2. It means that A row 1, column 2 is equal to -1. It means that A row 2, column 1 is equal to -3. And lastly, A row 2, column 2 is equal to 0. Now the way we add matrices, the only way we can add them is if they have the same order. Otherwise, we say that the sum is undefined. So for number 1, you're looking at the order. So remember, order is rows by columns, R, B, C. So the first one has 2 rows and 2 columns. The second matrix has 2 rows and 2 columns. So since they have the same order, we can add them together. So to add matrices, you're going to add your row 1, column 1 to row 1, column 1. So -1 plus 1. Then we're going to add row. Okay, sorry. Add row 1, column 2. So this is row 1, column 2. Let's call it A. A sub row 1, column 2 to row 1, column 2. And then we're going to take 0 plus -1, or 0 minus 1. So row 2, column 1. And lastly, 1 plus 2. And then you're just going to add those together. So we have -1 plus 1 is 0. 2 plus 3 is 5. 0 minus 1 is -1. And 1 plus 2 is 3. And that's your final answer. And this can actually be checked on your calculator. So using that packet that I gave you to check matrices, you would type in each matrix in for a letter, and then you would just hit A plus B on there. So try following the packet to do the best you can with that. I haven't figured out a great way to show the calculator on the videos. So at this point, do it by hand and give it a try on your own in the calculator, or I'll look for maybe a video of someone else doing it that I can find. All right, so for number 2, we have an order of 3 rows by 1 column. The second one is also 3 rows by 1 column. They have the same order, so we're going to add them together. So we've got 1 minus 1 gives us 0. We've got -3 plus 3 gives us 0. And we've got -2 plus 2 gives us 0. So our new matrix is just all zeros. And number 3, we have a 3 by 1 matrix. And then this one is 1 row, but it has 3 columns. So in this case, they are not the same exact order, which means this one would be undefined because they do not have the same order. All right, next let's talk about scalar multiplication. So it says determine the value of 3a minus b assuming A is this matrix right here and B is that one. So first I'm going to find just what 3A is. So I'm going to multiply 3 times matrix A. So putting a 3 out in the front, and I'm just going to distribute that 3 to every single term in there, which we talked about before with our scalar multiplication. So 3 times 2 is 6, 3 times 2 is 6, 3 times 4 is 12, 3 times negative 3 is negative 9, 3 times 0 is 0, 3 times negative 1, negative 3, 3 times 2 is 6, 3 times 1 is 3, and 3 times 2 is 6. Now I want to take that and I want to subtract B from that. So I'm going to write that out. So B is right here, 2, 0, 0, 1, negative 4, 3. So what we're really doing is we're negating everything in that matrix B. So be very careful. If it helps, you could make this addition right here and make everything negative, or just remember to be really careful and make sure you're subtracting. So 6 minus 2 gives us 4. 6 minus 0 is 6. 12 minus 0 is 12. Negative 9 minus 1 is negative 10. 0 minus 4, minus negative 4 is positive 4. Negative 3 minus 3 is negative 6. 6 minus negative 1 is 7. 3 minus 3 is 0. And 6 minus 2 is 4. Would be our final answer. And again, this can all be checked right in your calculator after you store in those matrices. Just type that into the home screen and it will literally give you the answer right back. Okay, so this one is a little bit different, but the same idea. Solving for x in this given equation. So first thing I'm going to do is I'm actually going to, off to the side here, I'm going to solve for x. So 3x plus a equals b. So I'm isolating x, so I'm going to subtract a from both sides. So I get 3x equals b minus a. Now I'm going to divide by 3 on both sides. So really x is equal to b minus a divided by 3, or I'm going to rewrite it as 1/3 times b minus a. So it's going to be easier for us to do multiplication rather than division. So making these two are the same thing right here, this one and the one I just wrote. Dividing by 3, same thing as multiplying by 1/3. So let's write this out here. So x equals 1/3 times, I'm just going to rewrite these matrices actually. So I'm going to take b, and I want to rewrite that one first. So negative 3, 4, 2, 1, minus a, which is 1, negative 2, 0, 3. Okay, so our order of operations, let's do inside of our parentheses first. So I've got 1/3. Now I've got negative 3 minus 1. So here, let me make this addition, and I'm going to change all the signs to show you a different way of doing it, which might work for you. So I've got negative 3 plus 1 gives me, oh, did I forget to make that one negative there? So we've got negative 3 minus 1 gives us negative 4. 4 plus 2 is 6. 2 minus 0 is just 2. And 1 minus 3 would give us negative 2. Okay, and now we're going to do our scalar multiplication and just multiply every single term by 1/3. So I've got 1/3 times 4 is 4/3. 6 times 1/3 is 2. 2 times 1/3 is 2/3. And 1/3 times negative 2 is negative 2/3. Should be our final answer. Again, you can type it in your calculator. Just store a in, b in for the two matrices, and then type in 1/3 times a minus b, and that will give you the answer. Okay, so now we're starting to get into matrix multiplication, which is a little bit harder because it's just kind of a strange process that you have to do. So let's say A is an m by n matrix, and B is an N by P matrix. When you are able to multiply matrices together, those middle numbers have to be the same. So this is rows by columns, so the number of columns in the first one has to be the same as the number of rows in the second one that you're multiplying. If those two are the same, number one, you're allowed to multiply them. Number two, it tells us that the new matrix is going to be of order M by P. So it'll have M rows and P columns. So first in number 6, we're just going to decide whether or not you could multiply them. So could it provide a possible outcome? And if so, what would the order of the product be? So again, you're looking to see if the middle two numbers are the same. In this case, they're not. So that would give us something undefined. It would not be possible to multiply those two together. Okay. Remember again, that order is rows by columns. So in letter B, we have 2 by 3, 3 by 3. So our middle numbers are the same. So the number of columns in the first is the same as the number of rows. If those are the same, then our new matrix will have an order of 2 by 3. Okay, the next one, middle numbers are the same. So the order would be 2 by 2. So here would be a good place to pause and try D, E, and F on your own. Okay, so hopefully you realize in D, it again would be undefined because the middle numbers are not the same here. In letter E, you'd end up with a 1 by 1 matrix, and in letter F, a 3 by 3. For the following, determine if the product exists, the order of the product, and the product itself. Okay, so first we need to know if it exists. So to do that, we need to find the order, which is rows by columns. So the first one is a 2 by 2. The second one is a 2 by 2 as well. So if they're both 2 by 2s, our middle numbers are the same, which means the new product should end up being a 2 by 2. Now we want to actually find what the product is. So here, and I can't really show you with my fingers, but usually what I do is I use one finger in matrix A to kind of guide what I'm looking at, and then I use my other finger and guide myself down in matrix B. So I'll trace it out for you what I'm doing. So the first entry is going to be row 1, column 1. Okay, so it's the first row, first column. So what we're going to do is we're going to take only the rows from the first one, and we're going to take only columns from the second one. So we're going to do the first row and the first column. So we're going to multiply and add together. So we're going to take 2 times 0. So 2 times 0, and add that to 4 times 5. Okay, that's row 1, column 1. Now let's do row 1, column 2. Okay, so let me change colors here. Row 1, column 2. So I'm still on row 1, but this time I'm going to do column 2. So this is row 1, row 2, column 1, column 2. Okay, so I'm going to take 2 times negative 2 plus 4 times 6. So you're multiplying the first two together in those rows and columns, adding it to the second two. Next one we'll do is going to be row 2, column 1. Oh, let me switch colors again. Row 2, column 1. So now I'm looking at row 2 and column 1 is my blues. So I'm going to do negative 1 times 0 plus 3 times 5. And lastly, we're going to do row 2, column 2. So row 2, column 2 are the green ones. Negative 1 times negative 2 plus 3 times 6. Okay, now we're just going to add and multiply together to simplify to get our final matrix. So we have 2 times 0 is 0, plus 4 times 5 is 20. 0 and 20 is 20. Then we have 2 times negative 2 is negative 4, plus 4 times 6 is 24. 24 minus 4 is 20. Then we have 0 plus 15 gives us 15. And then we have 2 plus 18 gives us 20. So lots of 20s here. Final answer. Again, this can be done in your calculator. Store in matrix A into your calculator, then store in matrix B, and then you just hit A times B in your home screen. And again, it will just give you the answer. The hardest part is just taking the time to type them in. All right, so now it's a bunch of practice. So let's do another one together. Be really careful. You want to make sure that you're doing it in the exact order that they give. So we're doing A times B for this one. So I'm going to take this one, we're taking only rows, and this one we're going to be taking the columns. Okay. Now, before we actually can do it, we got to make sure it's possible. So let's write out the order. So this one has an order of 2 rows by 3 columns, and this one has 3 rows by 3 columns. Our middle numbers are the same, so our new order is going to be 2 by 3. Okay, so AB equals. So we'll start off with row 1, column 1. So here's row 1 and column 1. So we're going to multiply 1 times negative 2 plus 0 times 1 plus 3 times negative 1. Next, we're still in row 1, but we're going to do column 2 this time. Row 1, column 2. And we multiply in order those numbers. So 1 times 4 plus 0 times 0 plus 3 times 0. Next is going to be row 1, column 3. Row 1, column 3. We've got 1 times 2 plus 0 times 0 plus 3 times negative 1. Next up, now we're going to do row 2s. So we've got row 2, column 1. So we've got 2 times negative 2, negative 1 times 0, negative 2. Oops, I think that's why I like to use my fingers there. I think I changed which column I was looking at. So we had 2 times negative 2 minus 1 times 1 minus 2 times negative 1. That's better. Okay, for the next one, we're going to do row 2 and column 2. So row 2, column 2. That's the entry that we're putting into our matrix. So again, this one is your first row, first column. This one's your first row, second column, first row, third column. But that's also what you take from each of the original matrices, what you're multiplying and adding together. So now I'm doing black. So I've got 2 times 4 minus 1 times 0 minus 2 times 1. And lastly, let's do purple. We've got row 2, column 3. So I'm doing row 2, but this time column 3, so purples. So I have 2 times 2 minus 1 times 0 minus 2 times negative 1. And then lastly, I'm just going to multiply and add all those together. So I have negative 2 plus 0 is negative 2 minus 3 is negative 5. And then I've got 4 plus 0 plus 3 times, wait a minute here. This one should have been a 1 right here. So we've got 4 plus 0 plus 3 is 7. And row 1, column 3, we've got 2 plus 0 minus 3 is negative 1. And then we're going down to row 2, column 1 is negative 4 minus 1 plus 2 gives us negative 3. And then we have 8 minus 0, so that's 8 minus 2, 6. And then lastly, 2 times 2 is 4 minus 0 plus 2. So 4 plus 2 is 6. So right here is our final answer. Again, check it on your calculator. Okay, so go ahead and hit pause and try doing letter C on your own. Okay, so the order of this one is 3 by 2. This one's 2 by 2. Middles are the same. Final answer should be a 3 by 2. And again, you can check this right on your calculator. I'll just give you the answer here in case you're having trouble using your calculator. And that should be your final answer. So you do it the same way, multiplying row 1 by column 1, and so on. And then letter D, find A, B again. So sometimes these are almost harder because they're so small when you have only one row or one column. So this is a 3 by 1, and this is a 1 row by 3 column. So our middles are the same. Final answer is going to be a 3 by 3. So it goes from something, both of them really small, actually becoming a much larger matrix. So when we do that, we're still taking row 1, column 1. Rows in the first one, columns in the second one. So it's just going to be 2 times 1. Then we're going to do row 1 still, and column 2. So then we're going to be row 1, column 2, so 2 times negative 2. And then row 1, column 3 would be 2 times negative 3. Next, we're going to do row 2 now. So we're going to take row 2, column 1. So negative 1 times 1. Now we're going to do row 2, column 2. So I take the first row as negative 1 times negative 2. And then row 2, column 3 be negative 1 times negative 3. And then our last row here will be row 3, column 1. So 1 times 1. Row 3, column 2 would be 1 times negative 2. And row 3, column 3 is going to be 1 times negative 3. And now let's write that out a little nicer and shorter. So 2 times 1 is 2, negative 4, negative 6, negative 1, positive 2, positive 3, 1, negative 2, negative 3. And once again, check it in your calculator. Okay, and this one is actually, I want to draw your attention that A has been switched. So if you look at letter D, that used to be B, now that's A. And B is what used to be A. So really what I'm seeing is I want you to notice that we're doing the same two matrices, but they're in a different order. We're really doing B times A according to D. Order is 1 by 3, and this one is a 3 by 1. So the middles are the same. Final answer will be a 1 by 1. So we're taking rows from the first one. So this is the first row. And here is the first column. So again, notice this is the same as letter D. It's just we've switched the order of them. So we're taking row 1 times column 1. That's really all we have here. So it's going to be 1 times 2 minus 2 times negative 1 minus 3 times 1. Add those all together. 2 plus 2 minus 3, so that's 4 minus 3, gives us 1. So AB is equal to 1. Again, check it in your calculator. Now, something else I want you to realize, these two were produced by just switching the order of the matrices. So is matrix multiplication commutative? And the answer is no, it is not commutative, because when we switch the order of the matrices, it gives you two very different matrices there. Okay, so your homework will be out of the textbook. So if you do have questions, you can email me or text me on Remind, and we can go over any of that, or if you have questions on what the expectation is, also just let me know. All right, I hope you enjoy the rest of your day.